Test. 1, 2, 3. Alright, let's get this over with. I turned off the fan, or else you'll hear it. Let's go. Wait a minute. Never mind, guys. I thought I made a mistake. Turns out it's just not a mistake. Oh yeah, Mr. Arif said I need to be more enthusiastic, so I'll try. Thermal conduction. Yo, okay. Heat through solids. How heat travels through a solid is through thermal conduction. It is the passing of heat through direct contact of particles to another. Whoa. So as you can see, there's like a metal bar or something. I don't really know. So the yellow is like really vibrating fast, and like the blue is like, oh, so sad, so vibrating little, you know. And the middle red is like, medium, kind of like in the middle. And so yeah, basically the yellow particle is like, and after that it bumps into the other orange particles, and the orange particles are like, oh damn, this guy vibrating fast. And then the yellow particle bumps into it, and then it bumps into it, it bumps into the other one, it bumps into this one. And then they all start vibrating really fast. But, you know, it takes some time to do that. So that's why the blue particles are still cold. Conductors and insulators. Some materials are better at conducting than others. These materials are called conductors. Metals are common conductors. Materials that are horrible at conducting are called insulators. Non-metals are common insulators. Metals are the best at conducting, while gases are the worst. So yeah, as you can see, there's some examples of conductors on here. There's a copper pipe, some, what is that, syringes? Tinfoil. That's wire. That's some gold. Insulators is it's a crumpled up bottle. Some scrolls. Some some black plastic paper bags, is that a paper towel? Yeah. See, the insulators, non-metals, conductors are metals. Easy. Yeah. Why are they so good? The reason the metals are so good at conducting is because they have loose electrons between their particles. The electrons gain energy and bump into particles, making them vibrate more and heating the particles up. So if you take chemistry, this is known as metallic bonding. If you don't take chemistry, this is known as, this is what inside metal is. There's like tons of loose electrons. Okay. Why they are so bad? Why the insulators are the way they are is because they don't have loose electrons like metals do. That's one of the reasons. Gases have no free electrons, and therefore they have to bump into each other to conduct their energy. This is very inefficient. Insulators like wool have pockets of air inside, making them good insulators. So like jacket, there's stuffed wool inside there, right? And the wool has stuffed air inside there, and air is a bad conductor, therefore a good insulator. So therefore, the jacket is a good insulator. Convection. Only in gases and liquids. Gases and liquids is where you could find convection happening. Convection is the liquid or gas circulating the hot and cold. So, as you can see, this like what is this? A bucket? No, you wouldn't hear bucket. Let's say it's a silver bucket, okay? And then you put it on a stove because you want it to heat up because, I don't know, you don't have a pan or something. And like the water ran out, and so okay, the fire, it heats up the water. So actually wait, I think it's explained in the next one. Yeah. Convection is liquid. So we know that if something is dense, it will sink, and if it's less dense, it will float. If we heat up water, it will expand, increasing volume. If the volume increases but the mass stays the same, the density will decrease, causing it to float. So yeah, so the water expands, but the mass stays the same, so the density decreases and it floats up to the top. Then the cold water, it goes down, it sinks to replace it. And then it gets heated up, and then it floats up, and then it's a cycle basically. That's what they call convection current. Convection on the beach. So, As you can see, there's the land, here's the sea. During the day, the land acts like a fire because the radiation, it hits here and then it reflects onto the air above it. However, the water, it absorbs some of the radiation. That's why it's a bit cooler and therefore acts like the cool water. And so the cool water goes down here, gets cold, moves up to the land, and then after that it heats up and rises up into the clouds, and then it moves over to cooler air, sinks again, and then there's a cycle. Convection at home, an example is when you have a heater. However, we don't have heaters because it's Malaysia, and if you have heaters, you probably live in Genting Highlands or something. And yeah, so hot air rises, and it goes there to the cold window, it sinks again because it gets less dense, it gets more dense, and it gets compact down, and it moves over to the heater again, and it rises up, and it's a cycle. Okay, thermal radiation. What is radiation? Radiation is a form of energy which is transferred by waves. It does not need a medium, so it can travel through a vacuum. Radiation has varying wavelengths. I'll explain that in the next one. Okay, here, as you can see, these are all the types of radiation. Maybe not all the types of radiation. I'm not sure if there are more, but this is what we see as visible light. Right here in the middle here, as you can see, that's what we see as visible light, and after that is infrared radiation. We can't see infrared radiation, it just does exist. And then there's microwaves inside there, and there's radio waves. That's how we communicate. And then what is that? Oh, computer waves. I don't know. And there's the extremely low frequency of ELF. Yes, ELFs do exist, and they are very low frequency. Okay, ultraviolet radiation. Ultraviolet radiation is not violet. We just call it that because, I don't know, it's closest to the violet side over here. And, infrared is closest to the red side. That's why we call it infrared. It's not actually violet because we can't see it. So X-rays is after that. And then gamma rays. Gamma rays is what you guys always hear in those fancy movies. I got hit by gamma rays and now I'm a guy who turns green, even though I got hit by purple gamma rays. No, I'm just kidding. They don't have color. So at the bottom here it says non-ionizing radiation and ionizing radiation. What these mean is that ionizing radiation, it can cause damage to your cells. So when it hits it, it's like it hits the cell like a bullet, like. So these gamma rays, think of them as cannonballs, and these ones as like BB guns, and these ones as like bullets. So, yeah, that's basically what ionizing and non-ionizing radiation is. Fun fact is that, actually, no, that's the next slide. Emitters and absorbers. So emitters are things that emit radiation. Absorbers are things that absorb heat or radiation. Heat and radiation are connected. So the best at emitting and the best at absorbing is dull black, and it goes down to shiny black, white, and silver. Silver is the worst at emitting and the worst at absorbing. So if you put a silver block outside and a dull black block outside, in the hot sun for 2 hours, and you bring it back inside and measure its temperature, you can see that the silver is at least a few degrees cooler than the dull black. Alright, greenhouse effect. The greenhouse effect is when greenhouse gases trap heat, causing a space to heat up. What I mean a space is that, for example, this is Earth, and there's greenhouse gases there, and the heat gets trapped. It bounces up and down. It gets trapped in there, and that's why global warming exists. And yeah, the production of these greenhouse gases is through breathing, farting, making plastic. I don't know, there's tons of sources, but we kinda ignore that now. Okay, so what I mean by causing a space to heat up, we can actually take advantage of this greenhouse effect by making a greenhouse. What a surprise, right? A greenhouse effect. We use it to make a greenhouse. A greenhouse, we can fill it up with CO2, which is a greenhouse gas, and that will trap heat inside the greenhouse. But that will also feed the plants carbon dioxide, which they need for photosynthesis. Bio students, okay. Solar panels. How solar panels work? I'm not talking about the solar panels that take in energy, because that's a bit more complicated. But I'm talking about the solar panels that heat up water. You know, the ones that you have at home or you don't have at home. I have them at home. Yeah, okay. So, cold water. Cold water is fed through a pipe and then it goes up to this thing and it gets pumped into the solar panel. And then it gets warmed up by the sun. So it gets warmed up by the sun and it goes back down into the pump here and it goes into your shower. But there's also a boiler here that can be used on colder days. But my house doesn't have a boiler, so every time it's cloudy, I have to take cold showers. And you know how much that sucks? That sucks, you know? You know, you just come back home from a long day of school, it's cloudy, you wanna take a shower and it's cold? That's horrible, okay. That's it. Goodbye. Wait. I can't click